architectural design document. Really quickly, we're just talking about LangGraph and
Hmm.
how it works for the A gateway. And I was kind of curious regarding, from a code perspective, how we're kicking this off and then kind of going through and getting each checkpoint, how the human in the loop architecture kind of works, and then how to kind of go about and synthesize this as someone who doesn't have as much experience with LangGraph. And then there's like some fundamentals that we should probably know and try to research on. And I think that would probably go to Alex or Mikola to best discuss this.
Sure, happy to jump on. I didn't really knew upfront what we exactly gonna discuss, so I don't have any stuff like the educational materials, so it will be
Yeah.
slightly chaotic. So please bear with me for a
Perfectly
moment. So I
fine.
think we let's split into some different sections because kicking the thing off and how the line graph works, I would say are closely related, of course, but they are different things. So the whole agentic flows, whether it be agentic chat or whether it be a dual workflow, the software development one, they are all, and there are like 2 or 3 more already. They're all being triggered in the same way, following the same architecture. So the whole thing starts at the executor, which is our client, and it kinda is also a little bit of mix of a client for the whole service, and also sort of an MCP, but not really. And it is sort of an MCP, but not really, mainly because we created the architecture before the MCP was broadly announced. So we weren't really aware of that protocol at that point in time. So we tried to come up with the best thing we could. In the hindsight, maybe we could do it differently, but it is how it is. So the executor both starts the things off by sending gRPC message to the service. And that gRPC message, it's, I believe, called start workflow message. It includes the necessary details to select correct flow and to kick it off. So mainly it contains the flow definition that kind of ties it to the LangGraph implementation, as well as some kind of metadata like the IDs, user ID, project ID, the things that connect it to the context in the GitLab platform. So this is how it starts in a very high level. I don't know if you have any questions. Should I go into some sort of level of details, maybe more?
Yeah, I guess the thing that I'm kind of curious about is like in our agentic chat. Let's see if my VS Code will respond. Yes, in our like chat agent workflow. And this kind of, I guess I've been kind of using this office hours. It's just asking general code sniffing things when I'm
Yeah.
going through the Duo workflow service. Is that we have our workflow of chat, and generally this is like the graph construction. If without even knowing much about LangGraph, I can kind of already get a sense of like, okay, we're pulling this chat agent,
Yeah,
we're
we
getting a
cannot
bunch
see
of
your VS
tools.
Code. So if you're discussing what you see there, then
Yes, that's exactly kind of what is there. But exactly like what
No, wait,
is
what they mean is, are you showing something on your VS Code?
oh, sorry. Yes. I think I was looking. Okay, this is thank you. Okay. So going back, I just was looking at our .proto class, which is basically our construction of our messaging architecture. Much like GraphQL, this encodes how we're sending our, I guess, serialized data from the Duo Workflow client. And here are our RPC endpoints: execute workflow and generate token. And I guess going back to the chat workflow, this is kind of where I'm trying to understand, at least from a code sniff perspective, I can gain a sense of like, okay, this is generally pretty self-explanatory and I think pretty easily written code. It's like, okay, I've got this tool set, I've got an agent, and then I've got a graph that I'm adding conditional edges accordingly. But I guess like what exactly is this providing us? And I guess to understand a little bit, it's like the state graph, what is actually being encoded within this, so I can maybe get a better sense of what actually outside of just a repository this is doing underneath the hood.
Sure. So the line graph itself and the state graph being like a medium to use this framework, it provides the structure in which one can embed the whole, or with which one can model the business process, any kind of business process, and it works as a great state machine, as a directed graph as well. So I don't know if you're coming from like the experience of from Ruby experience or not. If so, we could kinda consider it as a set of sidekick jobs that being triggered one after another, or like even a microservice architecture that you need to embed into some kind of structure in order to work together to accomplish different goals. And this is what the line graph does does for you, is that it provides you the tools to define the structure where the node, when the edges defines the how the execution in your business process that you model flows, and the nodes are actually responsible for executing some sort of business logics in this process that you model. So the state graph is just a container, so to say, and within this container, one adds nodes that represents the operations, the transformation that happens across the business process, and connect those operations with the edges, whether it be the edge which is executed or like which transfers without any kind of condition from node A to node B, or with the conditional edges that allows you to route between different nodes in the process based on some sort of condition. So let's say that one node fetches the user input, and user could select button A or button B, and based on the selected button, you could route like you will have like some attributes within your state in the line graph saying, oh, user selected button, and based on that information, you could route and say like, okay, if the button B, then go to branch B. If button A, go to the branch A. Does it make sense from the high
Yeah.
level point of view?
Yeah, from a high level point of view, it does. I guess in that sense of what is actually determining the handoff process between, if we go in here, we can see that there's these two level
Yeah.
edges. One is an agent that hopefully then will get passed off to the run tools in the sequential order. And I guess that kind of component is how does it know that this next is next after running the agent, you should do a tool run.
No,
And
no, no,
then
no. So those the nodes, so the operations in the process are being added separately, and the connections between are being defined separately in a very like explicit way. So you can see a little bit lower on the line 240 that there is this add edge, and it says run tool agent. So you can see that there is one connection between like kind of going back from the tools to the agent. And above that, there is the conditional edge that goes from agent, and it could go either to run tools or terminate the whole thing altogether.
Okay, so how I guess I'm pretty sure in somewhere in our process we are able to draw up these graphs, at least to
Yeah,
like
yeah,
represent to visualize them. How exactly do we do that? And maybe there's a docs that I could just read
yeah.
that.
There is a documentation. So there is the make command that you can use to draw the graph, and there is also a page that has all the graphs documented, like the diagrams for the graphs. Yeah, that's the one.
Great. Awesome.
Please start with the duo chat one. Don't try to read the software development.
Okay, do a chat.
Yeah, but we could go to the repository, to the gateway repository, and in there'll be rendered version of this graph, which is, well, it's readable, and this one it's not so much.
Let's go. Sorry. Okay, here. It's flat file.
And it will be in docs, I believe.
Let's do a workflow
Graphs.
service.
Yeah.
Great.
And
Okay.
now let's go to the bottom, we will go back to the software development one. Let's start with the chat. That's the simplest one that we have. And here you can see all this things kind of like visualized. So there are two nodes in our graph, the agent node and the run tools node. There's one conditional edge going out from the agent. This is like with the dashed line, where it could go either to tool use or it could stop. And there is this edge that goes back from run tools to the agent.
And that corresponds, if we were to go back to our code, okay, run tools, no, okay, two nodes, and this goes from agent to run tool, and then run tool to agent. It sets an entry point, okay, as agent. I guess this is a completely side topic, but as a relationship of this is why is this so complex? This software development context building and I guess supervised planning agent.
Yeah, so it's supposed to do much more, like handle much larger tasks on its own without much of a human input. So at first it's being asked to like collect the data, collect the information. So if you try to like slice it into the chunks, you will see three similar subgraphs like the one that you saw in the chat. With added things like the ability um, to request the approvals for the tools, which means that in some cases, like if the agent wants to run command on your bash terminal, you probably would like to say it up front rather than trust the AI to not make any mistake and accidentally like remove your home directory. So there's like bunch of nodes that were required to support this like additional plane control layer. And then there's like the three agentic loops. So what you see in a chat graph going back down is like the most simplified agentic loop that you can have. So you have the agent node, which is the call to the LLM. And there is the node that takes these calls from the LLM, the generated information from the LLM, and executes them somewhere, whether it be on your local environment, if you're running with the local executor or local MCP, or it could execute them in cloud, depends on like the environment and setup. And the more complex flows you try to model, those kind of loops will repeat itself and connect with each other.
Okay. Okay, that makes sense. And that's and just in here, in like in the sense, if we were to subdivide a subgraph, it's generally a call tool and then handover agent, and then I guess there's a planning supervisor. I was just looking at this one for the planning
Yeah.
section. I can see that the same thing, each has its own unique set of tools, a handover process to the next subgraph. And then I guess in combination to this is like, how do we know a termination sequence on a specific flow just through code?
I'm not sure what you mean.
Like
I mean,
in this
yeah, go ahead.
in this basic one, we have our agent node, our run tools,
Yeah.
and then we have a stop sequence. And how do we like codify a stop sequence? Or at
So
least,
how do we know when to stop the graph, when to stop the loop, right?
yes. Mm-hmm.
Okay, cool. Yeah, so well, it depends very much on also the flow that you try to model. Like with the most automated approach, so the agentic loop, the pattern that we are using is that there is this one appointed tool that agents are expected to call to signalize that, hey, I'm done. So the stop sequence is being triggered by the AI rather than by us. In the current implementation, that tool is called the handover tool.
Okay.
And this is like we just tell in the prompts, we tell the agents like, hey, whenever you believe that you are done, call this tool. And once we route out of the node that calls the LLM. So we have the LLM response. We look inside the LLM response to check whether we have this handover tool present. And in that case, we are just terminating, like triggering the termination sequence or handover sequence if there's like more agents chained together.
Go to the agent file, Nathan.
Let's go see.
No, I mean, yeah, just click it, agent.py. I think this one.
Yeah, in the prompt, that would be rather. You can see. Once you have all necessary information, you must call the handover tool. That's how we like extract it to execute it. And if you want to see how we are like actually routing on that, that would be in software development /workflow py.
Okay. So,
But overall, like it's up to us, it's up to developers how you define what is the end.
Yeah. That's the good point. Yeah.
So here, like in workflow, we say right now, so this is the final tool that you need to call to indicate that the loop is over. Or let's say in some other places, you can say that if there is a tool, you need to call it. If there is a row string, so that's the end of the loop. So it's up to a developer. So all
Yeah.
these connections that we have there, they all defined manually by developers.
Yeah.
So they can be static or they can be conditional, and developers they need to clearly explain what this condition means and how it looks like, saying
I
like,
guess
if you have this in the state, you go to node A. If you have this in the state, you go to node B. If you have this, or if you have nothing, let's say you end the graph, something like
Yeah.
that.
so. Can we hypothetically add different? Well, if as a developer we're controlling this, we can add conditionals of when to close. Like if we had a different software workflow, if we had a different workflow, we could have a customizable. And I guess part of you guys' work with this ADR is you can have a customizable state of like finishing. And can you have? I guess going to this diagram, can you have two states, like, or does this always have to be like a directly a DAG, the graph, to be like you can complete it at two different, I guess, portions? That doesn't really make much sense though.
So I think it's like you can also pause, like you can terminate or stop the graph execution at any node with like there's a dedicated tool in LangGraph called interrupt that allows you to break out of the graph execution at any particular node, and then LangGraph allows you to resume from the node that was stopped, the execution was stopped, to continue. This is what we are using for things like the human in the loop, exactly, or the tools approval.
Interesting. Okay, it's cool.
So, but yeah, like you can even try to restart the graph that reaches the end, like the end node, but then you will need to a little bit of like the LangGraph magic to tell it that instead of going to the node that you stop in, because if you stop at the end, then you stop at the end, you can also tell the LangGraph, okay, now jump to the start or jump to the node A or node B. This is exactly what's happening in chat. So whenever chat stops at the end, when we try to continue the conversation, we tell it to jump to particular like starting node. That would be in a get graph input, I believe.
It's like a go-to comment.
Yeah.
But honestly, the same thing. So we should be very, very careful with using these comments.
No. I think it's quite unfortunate that we follow with this approach at that point in time. It simplified the graph a lot, but we could do it differently. But it's there and it works for now. So you can see in the case
Awesome.
resume, and at the very bottom we return command, and there is go to.
Okay, so oh, interesting.
The more elegant solution would be to use the interrupt and have like the closed loop. So because we are kinda closing the loop without using the LangGraph. And more elegant way would be to just have this kind of infinite loop with ability to break out on the user demand. But yeah, it is it is what it is at this point in time.
Mikołaj, do you want to add any details about the flow registry? Just, as a top.
I'm not sure if I want to overload our audience right now. Like I think that the main takeaway, please correct me, Alex, if I'm wrong, like, is that we want to take all this complexity away, and that's why we like kind of try to come up and work really hard to provide this abstraction layer. So all these details and complexity wouldn't necessarily bother an engineer that is only interested in, okay, I just want to automate my process, like automate my code review or automate my security review or whatever, or even the issue deduplication. Like, I just only care about the prompts, and I know that if I tell the agent that, hey, work with this prompt and with this issue until you are done, and tell me that you're done at that point in time, it will work. That was like the very high level key takeaway.
Yeah, that's what I mean. Like, mainly to provide some components to get away from this low-level LangGraph API, so that we have some standardized approach how to work with this framework, because this framework is quite flexible. You can implement different things in very different ways, right? But if you, as Miguel said, if you start looking, into these graphs that we have right now, all of them, they have a lot in common. And the LangGraph, let's say, presents every agent as two nodes, right? No, I mean, yeah, it's a two nodes, right? The one where you make the LM call and the next where they execute exactly the tool, right? So you will see this combination a lot, like this loop that Mikolai presented in Duo chat, right? So this that we're just trying, to wrap up with components, so that as a developer, you mainly work with them, building the flows that that he needs, right? Because we need also some patterns, right? Like planner, reflection agent, simple agent, right? Let's say some kind of orchestration logic. If you have, let's say, two agents, let's say like a supervised agent, right? So you need some kind of components that you can just take and put them, connect them, and everything will be done, right? Instead of just always rewriting exactly the same LangGraph low-level logic.
Do we have that flow registry MR put into the AI gateway yet? Or is that still working on a branch?
So we have parts of it already on the main branch, but it's not fully functional yet. So not even the MVC is not fully functional. By that means you can really use it right now. Like, we need a couple more days to have the MVC in a functional state. It will be still very, very, very bare bones, and like because the main limitation from the user perspective would be the breadth of the set of the components that we offer. So the MVC would probably offer one or two, so it will be very limited in that sense. But like in a couple days, it should be like the first component or two available, plus the whole other, like the other plumbing and wiring built around that one can just go into the YAML, use this single component, chain it together, and get some results out of it.
Yeah, I know we have a hackathon for just GitLab in general, but I think that would kind of be a cool hackathon to build your own custom agent, like a day of, and then present it to GitLab and see what you could build. Because I think in general, that's the whole concept of what workflow and your customizable like catalog is supposed to provide. Is you build
What is the date for this hackathon? Or is it like just an idea that it would be cool to have this kind of hackathon?
We could, I think in general, GitLab's having a hackathon today. As I go to my calendar, yeah, July tomorrow. Tomorrow is.
Okay, that's a little bit too tight.
Yeah, no, just in general, this would be something kind of cool to at least demo, and I could see that being like, oh, build your own workflow, and then maybe by that time we'll have some type of
Like
catalog.
right now, just a tidbit right now, there was this like nomenclature change, so we should use flows instead of workflows.
Yeah.
And the run of a flow should be called session, because workflow was too broad of a term and it was super confusing. No one really know what it should be.
Yeah.
So we kind of abandoned that. So now they are called flows, and the execution of a flow is called session. And I hope it will stay that way. Fingers crossed.
Okay.
Like Nathan, I think we spent almost 1 week with Nikolai trying to start using the same terms, you know, when we made the first commit of the for the AUR, you know, because
Is the
talking
number
about
of
one
days,
agent, Nikolai was about another one, so yeah.
number of days that we've changed naming conventions for flow agents has gone back to 0. Hopefully, we'll stay so long.
That's probably the big goal, that we need to document all the things that we have right now, and even, let's say, the things that we are pushing right now with Nikolai. I'm also working at the same time with docs. Hopefully, I will push them this week as well, because we have an issue like that. Sometimes our docs, they are outdated, and
Mhm.
at the same time, it's not really clear, let's say, in the AI gateway what the core components are, right? So we can say right now that prompt registry is probably a component, but maybe we should have like a better documentation of how it works, you know, how to maintain this component. Maybe flow registry maybe could be an example of that, because we will have at least two, plus maybe authentication as the third component.
Yeah,
So yeah.
I mean, a flow for checking our docs and seeing they're up to date. I mean, the question is, do you want to trust the ability for making the change? I mean, it's be a curious experiment. I think I'm kind of curious how much of the docs would get modified that are, maybe need to be up to date a little bit more.
Yeah.
I have a question. So when you're reviewing LangGraph code, or it's a DSL, really, what do you pay attention to? Like what the catches that you're trying to verify when you code review this kind of the LangGraph code?
Yeah, like first of all, try to put a lot of care and attention to correctly encapsulate the responsibility of the edges, which is for routing, and the nodes, which is for transformations. Because at
Mm-hmm.
the early days, and it's tempting because you have the product of your most recent node in a state. And when you take a look, Nathan, if you could take a look at the chat graph, and there is this one conditional edge, and I mean in the code, in the VS Code. So we have this conditional edge, and there is this one method. So there's the name of the node from this edge is originated. Then there is the method that is called a router that is being executed by the line graph to determine where the execution should flow. And if
Mm-hmm.
you take a look at this router in here, you can see that it has the access to the state, the most recent state.
Mm-hmm.
And at the beginning, we saw this situation where the developers tried to do some kind of transformations in the
Mm-hmm.
routers. Routers shouldn't do any kind of transformation. They should only like take a look at the state and determine the next step. So this is one of the things that I try to pay attention to. The other thing is that, and I think it's harder to quantify, but it's important to find the right balance between the number, like in how many nodes you're gonna place in your graph. The more nodes you have, the easier it is to really define the responsibility, and like the easier is to test them and make sure that they are like working properly. But there is a cost to that as well, because
Mm-hmm.
each and every node creates a checkpoint. So the snapshot of a state at the current moment in the graph execution.
Mm-hmm.
And this is like related to the additional call to the GitLab Rails that stores our checkpoints. And it also like creates more of like the data footprint of the flows. So there's the cost to adding more nodes to the graphs.
Mm-hmm.
So there's like there is this balance to be found between the having too many nodes and like I don't know, splitting every function in like one liner just to have yet another node because it's possible and maybe it's easier to test. And also, okay, I'm just gonna like put everything and put all the logic and create
Mm-hmm.
great if-else statement within single node.
Mm-hmm.
So I think that's the other thing that one should really be aware of. And another gotcha with the line graph that is important to remember is that the line graph is what it manages the framework. It's what manages the state updates. So in order to understand what data should be returned from the nodes, one need to take a look at the state that is being used for this particular graph. I guess I can take a screen share for a moment.
Yes.
So, okay, there's a bunch of things. So, and it is state. Let's close the. So, where we have workflow state. Here it is. So we have this class with dictionaries, this structs that defines the structure of a state that the nodes will work with, as well as the how those so how the keys within this dictionary within the states will be updated. Some of them are like by default, line graph just overrides your the old value with a new value. But one can override this behavior with the annotation, and then it's possible to define whatever reducer is necessary. And when upon the review of the changes to the graph, about review the adding some new nodes or changing how the nodes behave, it's important to take a look on okay, what is being returned and if it really makes sense in context of the state. For example, like if somebody will say, "Oh, I have this looking at the software development graph," so let's look at the software
Yeah,
development.
I think we can say that, you know, every node updates the state by returning some
Yeah,
like by returning like this updates from the node, right? And then it's up to the annotation what to do with this update. So this update can, by default, it fully replaces what we already have in the
yeah,
state. Or if you have a special annotation, you can append, let's say, your update to what you already have in your state.
yeah. That's correct, and it's important to make sure that the what is being returned matches what is defined in state.
Yes, yes, yes.
Because otherwise, like it can just break your data. And it can create like this hard to spot mistake because there will be no error, but your flow will behave in a strange way. So we can see that there's this method that return like, and it needs to. So this is like the method that return the data that LangGraph will use to update, as Alex described. And if you take a look, there is the same keys like the same keys within this definition and with return value. And in here we define that it is possible to return despite that in here is defined as the dictionary of string keys and the lists as the values. The return value in here would be dictionary with a string and the base message. So it's not matching, but it's expected by the reducers that will just take the key value and append it to the list. If somebody would make a mistake and say like, oh, I need to update the conversation history, so they will be like, I'm gonna take the current history and append it at the end. I got lost.
Yeah, you exited.
Okay, I don't. So yeah, let me try to screen share again for a second, and I promise I won't exit. Or I hope I won't exit. At least intentionally. So I said one could just try. Okay, I need to update, so I'm gonna append in here. So say like, oh yeah, self name, and then so something like this. Like it may look okay, just in the context of this code, but if this what is being returned does not match the expectation in here, the result would be that the whole complete history would be appended instead of the last message. So we have like a double the history, and it will just confuse the agents later on. So this is like I think one of the bigger gotchas that one may fall into.
So yes,
Yeah.
probably this is the key for us as reviewers. We need to understand how state looks like and what actually we update and what reducers we have in the state, right? Because it depends on what you need to return from the node. Should it be the full state? Should it be just a partial update? So yeah, this is the thing we need to consider.
Yeah. So I think that would be like the key guidelines.
Like we probably also need to try use less row strings, right? As we discussed that with Miguel, right? Because if you may notice that in the nodes we access the state by the row string keys, right? And let's say if you make a mistake or if you rename the key in the state itself, so you also need to rename other row strings across all of your full code base, right? Which is quite complicated. But that's the problem that is not solved right now in the current code base, but we are solving that separately.
Yeah, and I think the other thing about the flows, it is which is not really strictly necessarily related to LangGraph itself, but the whole platform that we're building is taking extra care about security, especially about the control planes that we have built in. Because like last thing we would like to have is some unsupervised AI ability to execute all kind of things on your environments. And I can link later on in the architectural blueprint. There is this section, this more or less up to date, one of the most up to date section that we have there, that describes the whole system that we built to grant users the control over what actions AI are being allowed to take, in which actions they need to ask for permission, and what actions are off the table. And in the context of review, it's more to take a look at if any kind of tool executions that are being run in the graph either works with the tools that we believe that are secure and don't require any kind of approval, or these approvals are being verified and respected.
Cool. Thanks. I know we are coming close on to time, and I think maybe if we have a little bit of time talking about metrics too, I don't know if people how much time if people have,
What
but
if we leave this for the next turn? Because there was a lot of information already on this one. And I think if we come back next time, it just makes it easier just to set up. And we already have content for the next one now. What do y'all think?
yeah,
Make sense? Cool.
it's great.
Well, thank you, Mikolai. Thank you, Alexander, for this, especially on the notes on how to review this code. I really appreciate it. It's going to be helpful for onboarding new ones. Thank you.
Thank you.
Right.